So work energy and power assignment being solved from question 9. So in question 9, a jet ski is a jet propelled vehicle, means water will come out that moves across the surface of the water. So this is moving across the surface of water. It intake water and then there will be a water outlet. To propel the jet ski, to propel the jet ski forward, the water is drawn. Like if a jet ski is moving forward, what will happen? The water is drawn through an intake, so water there will come in intake, and then it eject through a water outlet at a high speed. So it will come out at a high speed. Explain why the cross-section area of a water outlet is smaller than a cross-section area of water intake. So what is the reason why the areas are different? Because the amount of the water which will enter will be same. So the one which is having a less area, there will be a greater change in the speed. So as this volume of the water which is entering as leave is same every second, so the flow rate so the amount of the water which enter will be same as the amount of water which leave. But the amount of the water which enter per second, the total volume will be same, like total volume per time, amount of the water or the volume of the water per unit time will be same, which is coming in and which one is going out. So the one which is having a large area, the flow of the water will be, this is the velocity, because like volume is area multiplied by length, so area multiplied by length divided by time. So here length divided by time, same thing, volume will be area multiplied by length divided by time. So the one which is having a, so this product will be constant, the volume will be equal to area into length divided by time. This should be constant. So for intake, the area of the surface area is more, the area of the intake, the area through which the water is coming in, that area is larger. So the water will flow at a slower rate. But what will happen for the other side, the outlet, the water outlet, which is having a small area, then the flow rate of the water will be higher. And what is the advantage? That water will have a high flow rate. So when it will have a high flow rate, it will have a greater resultant force. When it is having a greater resultant force, this will create more force for this ski to move over the surface of the water. So the idea is that like example, if this is a water intake, this will be the water outlet. Amount of the water which enter and leave is same every second. But because the side where it is taking a water, that is having a large area, so the flow rate is smaller. But the other side which is having a small area, the water must flow, a greater amount of water should flow every second. When greater amount of water will flow every second, it will experience, because like there is a more change in the speed and more greater acceleration, as a result it will experience a greater force. And when there's a greater force, it will be easy to move this ski over the surface of, or jet ski over the surface of water. Is it clear, the concept here, how this jet ski can move over the surface of water and why the cross-section area of outlet is more than the water intake? Any doubt in this? So the answer here, explain why the cross-sectional area of water intake and outlet should be same. So as the same amount of the water enter and leave, the one which is having a small area will have a greater flow of the water or greater velocity at which the water leaves. So it means there will be a greater change in the speed. As a result, there will be greater force, so it can easily propel this jet ski. Explain using Newton's law of motion how the ejection of a water at high speed result in a forward propulsion of a jet ski. Like why this jet ski will move forward. Look, according to Newton's third law, that action and reaction forces are equal but opposite in direction. So jet ski is applying a force on the water as the water is pushed, like because jet ski is pushing the water. So jet ski is applying a force on the water. As a result, the water which is going out will apply force on the jet ski. So it will create a Newton pair force. So jet ski is applying a force on the water which is coming out. As a result, water will also apply a equal force but in opposite direction to on the jet ski, and due to this, it will create a resultant force on the jet ski. As a result, it will create a resultant force on the jet ski, and when there is a resultant force, what will happen? This jet ski start to accelerate because, like if I say the jet ski is applying force on the water, say this is 10 Newton. As a result, water which is coming out also applying force on the jet ski, that is also 10 Newton. And due to this, there will be a resultant force on the jet ski of 10 Newton, and this 10 Newton will create an acceleration. So the jet ski start to move on the surface of water. So according to Newton third law and Newton second law, you have to use, like according to Newton third law, there are pair forces. The force on the water from jet ski is same as the force by the water on the jet ski, which create a resultant on the jet ski, and that's why it accelerate according to Newton's second law. So this is Newton's third law, where this one is Newton's second law. Then a man on a jet ski is heading away from a coast at a speed of 19 meter per second in a direction 30 degrees to the south of east, as shown. As you can see here, the scale is given 0.5 centimeters, 1 meter per second. Then there is a current in water 6 meter per second due north. So north is up, and there's a current. So we have to draw because 0.5 cent 1 meter per second is 0.5. So 6 meter per second will be equal to 3 centimeter. So the velocity of the jet ski has been drawn to scale on a vector diagram below, with a scale 1 meter per second is equals to 0.5 centimeter. What we have to do, we have to find the resultant and direction of the jet ski. Direction here refers to angle. So how to work out the resultant? They mentioned the water current is there in north. 6 means that is equals to 3 centimeter. 3 centimeter line we will draw, and that is in the direction of a north. Now, how to get the resultant? Resultant is from tail of the first to the head of the last. That will be our resultant. Now, what about the resultant velocity? So we will check how much. Like example, say this is 8.4 centimeter. Example. So this is 8.4. We have the scale that 0.5 centimeter is equals to 1 meter per second. So 8.4 centimeter will be x cross multiply. This will be 16.8. So the 16.8 is the final. Then what about the angle? We can measure, like we can measure the angle here. This one is north, south, east, west. So we can measure the angle from east, or we can measure the angle from south. Like if I'm measuring the angle from east, then I will say this angle is angle of the resultant south of east. So we can measure either this angle or the angle from south. to get the resultant. The direction of a jet ski here refers to the angle. The next question. A box of mass 0.5 kilogram is moved from the ground to a shelf at a height of 1.5 meters. The student is asked to calculate the energy transfer as the height increases. The student could use either of the formula, explain how two formulas are equivalent. Like how the two formulas are same, there is no difference between the two formulas. Basically, whenever the work is done, the energy will transfer or energy stored. So work done is equals to energy. What about work done? Work done is force into distance. And whenever we are lifting an object, the force which we need, that is equals to the weight of an object. And weight of an object is mass into gravity. So in place of mass, in place of force, we can write mass into gravity. And the distance which we move, that is h, the height, so mgh. So it means the work itself is equals to energy, which is mgh. So the work done, which is a product of force and distance, or the change in the work done is a product of force and distance. So force is equals to the weight of a object. As we are lifting an object, it's not always force equal to weight. This is always the case when we are lifting an object, force is equals to weight. And the distance which we move, that is a height, so h. So work done is equals to mgh. And that mgh is also equal to gravitation potential energy or energy. Calculate the increase in gravitation potential energy. We just have to substitute the mass. The mass is 5, the gravity is 9.8, and the height is 1.5. So when we substitute, we'll get the increase in gravitation potential. What is the elastic strain energy stored in a wire when it is extended by 4 millimeter? So this part is actually one part is missing here, like related to the spring constant image. And elastic strain energy or energy stored in a spring is given by half force into extension. This is a formula to calculate the elastic strain energy, or half k, because F is equals to kx. So half kx square is there, or it will be x is equals to, because F is equals to kx, so x is equals to F divided by k. In that case, it will be energy will be equal to half F square over k. But we need another thing, because we cannot find only from extension. We need either a force or a spring constant. The question is not complete. The figure is missing from this. A ball of mass m fall through a height h. What is the kinetic energy between the halfway? So how we will know how much the kinetic energy is there? Like if an object is at certain height and it is falling, so the mass of an object is m, the gravity is g, and the distance height it falls. So the potential energy at this point will be equal to mgh. But they are asking for half. If they ask what is the kinetic energy at this point, the kinetic energy will also be mgh, because if there is no energy loss, all the potential energy changes to kinetic. But in halfway to the ground, what will happen? Half of the energy will be potential and half will be kinetic. Like if it was 100 joule of potential here it will have a 50 joules of potential the halfway and 50 joules of kinetic. and here it will have all the kinetic, which is 100. So the question is, what is the kinetic energy halfway to the ground? So the potential energy is mgh halfway to the ground. The kinetic energy will be half of the potential energy. Potential energy divided by 2, and potential energy is mgh. So it will be mgh divided by 2. So B will be the right answer. Is it clear?
Yes, sir.
The next is the graph shows how the force applied on the board vary with the distance moved during a one complete stroke. Use the graph to show that the work done on the board during one stroke is about 500 joules. This is a non-linear graph, so it's not having a definite regular shape. We have to divide this graph into parts. Whenever force and distance graph is there, the area under the graph, remember, look, area is equals to the quantity on y-axis multiplied by quantity on x-axis. So on y-axis we have force, on x-axis we have distance. So force into distance is work or energy. So basically, the area of the force and distance graph will give us the energy of work. Now it's a non-linear graph. So for a non-linear graph, we have to divide into sections here. So first draw equally spaced vertical lines. Then equally spaced horizontal lines. And first we will count the complete boxes. So we'll start with the complete boxes. This one is say 1, 2, 3, 4, 5, 6, 7. Then this one is 8, 9, we have 10, 11, 12, 13, 14, 15, 16. But this is always estimation. So this is about 17, 18, and 19. So 19 of them appear to be a complete boxes. Then what we'll do, we'll count. If it is half or more than half, we'll consider as one, or otherwise we'll combine the two. So till here 19, then this I can count as a 20, 21, 22, these two 23, these two 24, this one is 25, 26, 27. So I have total 27, and this one is about 28. So I have example total 28, number of the boxes 28. Multiply by area of each box. So what about the area of each box? Like here, this is 0.2, and this one is 100. So 0.2 into 100, which is about, which is 20 actually. So when we multiply 28, so it will be 56, and then 0 will be there. So it will be 560. This is meter and force Newton, so it will be Newton meter, or we can also say Joule. So it is about 560 Newton meter or 560 joules. Is it clear?
Yes, sir.
So that's how we do or solve a question in which we have a non-linear graph. Hence, calculate the average power developed. Average stroke rate is 24 strokes, like 24 times. The strokes are there every minute. So in 1 minute, we have 24 strokes. We want to calculate the average power. Power is work divided by time, because the formula for power is work divided by time. Now, first we will calculate and time should always be in seconds. So for each stroke, because we need average power, so one power is work or total energy which is used, because that area which we calculated, like example, our answer was 560 or 540. That is the area of that is the amount of energy used for one stroke. So 500, even for example, if you are not able to solve this part in exam, but you can use this number here. For example, you try to get the answer, but you're not getting 500 or around 500. Then what you will do, you can use this number here, which is given. So I can also use this 500 in my next part as it is related. So power is energy divided by time or work divided by time. So work example 500. But what about the time? 24 strokes per minute. But we need how many strokes are, like how much time it will take for one stroke. So 1 minute means 60 seconds. So 60 seconds divided by 24. So we'll know that each stroke is about 2.5 seconds. The time is 2.5. So we divide by 2.5. We'll get around 200 joules per second or 200 watts. The work done by the rower is greater than the kinetic energy gained by the rower and the boat. So just two reasons. Like here, a rower who is doing a work done and he's doing a greater amount of work done, but the kinetic energy which is gained by the boat is less than amount of work he's doing every stroke. So what might be a reason for that? Or what is the reason? Like for every stroke, he's not able to, like he's producing more energy, but as a result, smaller amount of kinetic. So there is always like a drag is there, or a friction is there, or a resistance from a water. And another thing, when he's stoking, so some of its energy transfer to the water as a kinetic energy of the water. Like water will also start to move as he's stoking. So the two reasons, some energy lost due to friction. So there might be an energy loss due to friction. That is one of the possibility. And the second one is that some energy transfer to the water. That's why the kinetic energy of the boat is less than the energy which he used to stoke. Suggests why the rower and the boat gain different amount of kinetic energy during each stoke. So what is the reason why they have different velocities, different kinetic energies? Look, when the rower is stoking, the boat, like there's a person inside. So boat and the person both are moving at the same speed. But what happened? The mass of the person is smaller as compared to mass of the boat. So that's why if they have the different masses and they are moving with the same speed, the kinetic energy of the person will be different from kinetic energy of the boat. So answer here, why they get different kinetic energies as they're moving with the same speed as the person is inside the, or a rover is inside the boat. So they are moving, or it is moving with the same speed. So kinetic energy, why it is different? Because the mass of a person is smaller or different from mass of the boat. In question 14, a lift and its load combined mass is 650 kilogram. The lift moved upward to a vertical distance of 114.25. Approximate power is there. So power is equals to force into distance divided by time. So force is equals But here in this, so force is equals to weight. Okay, force is equals to weight of the person as it's lifted there, which is having a load 650. So 650 to 9.8, that will be the weight, the force. Distance is 140 and divided by time is 25. So when we simplify, it will give us about 40,000 watt or 40 kilo watts. 40,000 watt or 40 kilowatt will be the power developed by this. In question 15, a pogo stick is a toy which is used for jumping up and down. The pogo stick contains a spring which is under compression. The force in compression graph is given. Determine the spring constant. How we can determine the spring constant? We just have to take 2 points and find the gradient of this y2 minus y1 over x2 minus x1. One thing, if your extension or compression is given in centimeter, then answer will be Newton per centimeter. If it is given in millimeter, the answer will be Newton per millimeter. In part B, inside a pogo stick, the spring is compressed by 3 centimeter. A child jumped onto the footrest of a pogo stick and the spring compresses further by 6 centimeter. Already 3 centimeter spring is compressed, and then when the boy jumped on the spring, it compressed by 6 centimeter. The pogo stick and the child move up at a maximum height in position 3, as you can see here. The spring compressed 6 centimeter, original spring length is there, and the pogo stick and the child at a maximum height. Use the graph to show that the work done by the child on the spring is about 130. So how we can show that the work done is about 100? So as I mentioned, whenever the force and distance or extension graph is there, the area under the graph will give us the distance. So this is compression for the total spring. The graph is there. So what height we will take? We'll not take 6 centimeter, we'll take 3 centimeter. Why? As I already mentioned, that normally when the spring is there inside the pogo stick, the spring is compressed by 3 centimeter. So spring is already compressed by 3 centimeter. And when the child want to jump onto a footrest of a pogo stick, the spring further compresses or spring is compressed by further 6 centimeter. So what we have to do, we have to calculate the area of this graph. Like spring is compressed till this point, it is already compressed. Okay. Then when a child is there, he further compresses by 6 centimeters. So the total will be how much? The total will be 9 centimeters. So already spring is compressed 3 centimeter. When the child pushes the spring, it further compresses 6 centimeters. So total spring, how much it is compressed? To 9 centimeter. Now what we have to do, we just have to calculate the work done by, we want to calculate the work done by the child. So work done by the child is this part. So work done by the child is this part. So we have to calculate area of this part. So there are 2 ways. Like first I will find the area of the total from 0 till 9, and then I get the area from 0 to 3. This is a triangle, half base into height, and I will subtract. That is one way. What is the second way? I can just find the area of this part, which is making a trapezium. So half sum of the parallel side into height. So it will be half 1 by 2 sum of the parallel sides into height. So 1 by 2, the parallel side, one is from, this is 1 and this one is 3.3. So it will be 1.1 plus 3.3. 1.1 plus 3.3 and into the height, that means the distance between the two parallel sides, that is called h, which is equals to 6. So we substitute, we'll get about 128 joules. Or the second way, you will find the area of the total, like from 0 to 9, then area of 0 to 3. In that case, it will be half base into height. But remember one thing, that this height from 3 to 6, remember from 3 to 9, that is 6 centimeters. 6 centimeters, so you have to convert into meters. So because the unit of the energy is joule, and joule is Newton meter, not Newton centimeter. Here it is in centimeters, so we have to convert into meter when we are calculating the answer in joule. So we divide it by 100, or it will be 6 exponent minus 2. Is it clear? This one? How
Yes,
to
sir.
work out the amount of, so it was already 3 centimeter compressed, and then student further, or a boy compressed further by 6 centimeters. The total compression is 9 centimeters. But we just have to calculate how much energy used by the boy or the work done by the boy. And then when the spring is at its original as shown, the child is at its maximum speed. State the energy transfer that occurs as the child moves upward from position 1 to position 2. So when the child is moving from position 1 to position 2, the elastic strain energy converted into kinetic and potential, because he's at certain height as well and he's moving as well. So kinetic plus potential both will be there. The next part, by considering the energy transfer as the child move upward from position 1 to 2, calculate the maximum speed. So as we want to calculate the maximum speed, the total energy, the work done by the child on the spring, is equals to potential plus kinetic. So here, the work done by the child, because he's gaining the height, the potential energy will be there and there will be a kinetic energy. And potential energy is mgh plus kinetic energy will be half mv square, or 0.5 mv square. And that's a work done. So how much work he did? That will be 120. So we just substitute the value of the mass and the height to get the value for P. It will about 2.5, which is about 2.5 meter per second, 2.48. So which is about 2.5 meter per second. So as the energy, by considering the energy transfer as the child move upward from position 1 to 2, we have to calculate the maximum speed. And remember, like what height we will take. See, he moved 6 centimeter. So with 6 centimeter means we will take that as 0.06 meter. So we'll calculate the potential, because the energy stored here is the elastic strain energy. But when he moves, it will have potential and he's having a maximum speed, so he will have kinetic. So both energies are, the potential is mgh and kinetic is half mv square. So the total elastic strain energy is the sum of potential plus kinetic. So we'll calculate the speed in this manner. Then between 1 and 2, the pogo stick is pushed down onto the ground with reference to Newton's law of motion. Explain how this downward force caused the child and the pogo stick to rise. So what happened? Look, there's a gravitational pull of the earth on the child, and like there's a gravitational pull on pogo stick and the child by the earth, and the child and the pogo stick is attracting the earth. That is one pair force. The second pair force is the downward force by the pogo stick on the ground equal to upward force from the ground on the pogo stick. Now, what happens as a child pushes downward? As a result, there will be a greater downward force, or there will be greater upward force. And this upward force is more than the gravitational pull of the earth. As a result, it will create an upward acceleration, or this pogo stick or a boy with a pogo stick will accelerate upward. So the pogo stick is pushing down on the ground. So the ground is exerting an upward force on the pogo stick. That is a Newton pair force. And the upward force of the pogo stick, this upward force of the pogo stick is greater than the weight of the gravitational pull on the boy. As a result, it will have an unbalanced force, so which cause an acceleration upward. Is it clear this one?
Why it is greater?
Because see what
Like
happened.
why it is not equal?
Because that is not the pair force. Example, the weight of the person or weight of the boy and the pogo stick example, it is 60 Newton or 600 Newton. And they are pulling the earth also by a 600 Newton. That is a Newton pair force. Okay. Then according to the Newton third law, a pogo stick is applying force on the ground. Say this force is about, because as the boy is pushing it down, so this force is about 700. So as a result, the ground will also apply an upward force of 700. As a boy is pushing it downward, so there will be already a weight is there plus the 100 Newton from the boy. So as a result, there is a 700 Newton downward. According to Newton pair force, 700 Newton from the ground. So this 700 Newton from the ground, which is not the pair force of the weight, is more than the weight of this hole. As a result, 700 Newton up and 600 Newton down. So it will create an acceleration of 100 due to a resultant force of 100 Newton. So these two forces cannot be same. Why? Because they're not pair force. Pair forces will be equal but in opposite in direction.
Yes, sir. 700 is exerted by the boy, right? He's pushing on the ground.
700 is the downward force, which is the weight of the boy plus the extra force which is applied by the boy. Because weight is already 600 plus he is pushing the ground, example with a force of 100, so total downward force will be 700. So if total downwards is 700, the total upward will also be 700. And as a result,
Okay, sir. Clear.
this upward 700 is more than the weight or gravitational pull of the earth. That's why it will create a resultant force, cause an acceleration. So these are the questions from assignment, work, energy and power.